Okay, so today we're going to be looking at GCF factoring and regular factoring. So we're going to be dealing with things like this that look like this, so just some quadratic expressions. So before we get started, we just want to talk about what is factoring to begin with. So factoring is writing a polynomial as a product of polynomials. So product just means multiplying. Okay, so factoring a polynomial is going to be writing that polynomial as a product. So I'm going to be multiplying two polynomials together. So this would be polynomial number 1, and this would be polynomial number 2. So they're being multiplied by those sets of parentheses. Okay, so then what's the difference between that and simplifying? So simplifying is when we write our polynomial with all like terms combined and no parentheses. So that is like when we added, subtracted, and multiplied polynomials last class. And then lastly, what does it mean to solve? So solving is going to be when we actually get a variable is equal to a number. So we're going to get an answer. And then how can I check to make sure that I answered the question? So really just making sure that we understand the difference between those different words. Okay, so let's start looking at factoring. So our first form of factoring is going to be greatest common factor, or I'm probably going to call it GCF more often. So that is the number one rule that we're going to be looking for first. We always want to try and get rid of a GCF. So let's try and do that. So we want to find the GCF. So I'm looking for the greatest or the biggest common factor. So the biggest number and or letter variable that is in common in all of my terms. Okay, so, and again, factor, that means that factors are being multiplied, right? So if I look at 12, 18, and 6, I'm thinking of the factors of 12, 18, and 6. And I'm looking for one of those factors to be reoccurring in each and every one. So to me, the one that sticks out first would be 6. 6 goes into 12, right? 6 goes into 18, and 6 goes into 6. So that's my GCF. Found it. Now I want to factor it out. So when I factor it out, that means I'm going to divide it out. And I'm dividing each and every term by that GCF. So I have my 6 here. When I divide my first term, 12x squared by 6, I'm left with 2x squared. Right? When I divide my second term by 6, I'm left with negative 3. That's a close one. Negative 3x. And then I would be left with just a 1 on my last term. So that is me dividing out that GCF. But remember, factoring is writing a polynomial as a product of polynomials. So we are going to cover, after we do some GCF stuff, we will cover how to factor this. But right now, I took this out, and now it's not being represented that I took it out, right? This expression here is not equivalent to that expression. I have to show that I took something out of the original, like that. So this is just kind of like reverse distributive property. If I was to distribute this 6 back into my factored version, I will get my original back out. And that's what we want. So this right here, that is my factored answer. Okay, let's look at example 2. So again, I'm looking for the biggest number and or letter that can be divided out of every term. So if I look here, I have this term, this term, this term. factors of 7, 14, and 21 that all three have? I think it's just a 7. 7 goes into 7, 14, and 21. Okay. Now let's look at my letters. Is there any letters that all three terms have in common? I'm seeing a Y, a Y, and a Y. That's good. That means I can take it out. So let's divide every single term by that GCF, which is going to be 7Y. So if I do that, let's divide it out. Right here, I'm just going to be left with this x squared, right? Everything else is being divided out. Here, I'm going to be left with a 2x. And then here, I'm just going to be left with a 3. And that is my final answer. Okay, let's do one more together and then you guys can try on your own. So example 3. I'm looking at my numbers. I have 24, 8, and 40. The biggest number that goes into all three of them, I'm thinking is going to be 8. And then I also noticed that all three terms have some sort of x in there, right? So I'm looking at the biggest amount of x's I can take out. So to me, it looks like I can only take out 1 definitely from 3 of them. So my GCF is just 8x, and I will be left with 3x squared plus x cubed plus 5. Okay, now while that is correct because we took it out in the order, we took out this 8x in the order that it was given to us, let's put it in standard form because that is always the best practice. Okay, so that is our final answer. Okay, so I want you guys to try 4 through 7. Come back and let's see how you did. Okay, number 4. It looks like to me our GCF is 2xy. And if I divide that out, I will just be left with this. Seems. Example 5. I see a 3z squared. And I will be left with negative 4. And then just plus z squared. So again, let's make that in our standard form. And we're going to have that is our answer. Okay, example 6. I see each term has a 6 and an x squared. If I divide that out, I'm just left with x plus 3. And then 7. Not many numbers here to deal with, but plenty of letters. So the most amount of x's that I have in all three terms is just 1. And the most amount of y's that I have in all three terms is just y cubed. So I have my GCF is xy cubed. Once I divide that out, I am left with that. And that is as good as it's going to get right now. Okay, before we get into factoring binomials, I want you guys to FOIL these quickly and then see if you notice any relationships or patterns being formed here, specifically with my numbers in my factors. Okay, see what you got. Okay, so once we FOIL these, we are left with x squared plus 11x plus 24, x squared minus 10x plus 24, x squared plus 5x minus 14, and then x squared plus 6x minus 27. Okay, so did we come up with an idea of what the relationship is? I'm seeing a relationship or pattern when I look at the numbers in my factors and their relationship with the numbers in my polynomial. If I look at 8 and 3, I see that 8 and 3 can be added to give me that 11. I also see that 8 and 3 can be multiplied to give me 24. Let's see if that's the same across all of these examples. Is -4 minus 6 -10? It is. Is -4 times -6 positive 24? It is. Okay. Is 7 minus 2 5? Yeah. Is 7 times -2 14? It is. Is -3 plus 9 positive 6? It is. And is -3 times 9 -27? It is. So the relationship or pattern here is the numbers in my factors can be added to get the middle number and can be multiplied to get the last number. Okay, so that is the relationship that we're going to be looking at now. So right here, I gave you the factors, right? Oh, factors. And we had to come up with the polynomial. So now we're going to look at it reversed. So I'm going to give you these. And we want to work backwards to get those. So let's see how we can do. So my first example, x squared plus 10x plus 24. So first things first, we always want to remember to use rule number 1 first. That's the GCF. Is there any GCF here? I'm not seeing one, so that means that we are good to go ahead. So I'm going to go back for a second. The relationship was, right, these numbers here, this one and this one, added to get my middle number and multiplied to get my last number. So that's how we're going to figure out what those numbers are. So now I have what they're adding and multiplying to. I know what they're going to add to. I know what they're going to multiply to, but I have to figure out what they are. So if my numbers are going to multiply to 24, let's see what the factors of 24 are and see which pair of those factors will add to that 10. So let's list out my factors of 24. And that's it. Okay, so I have my factors of 24, and I'm looking for the pair that will add to 10. So I'm seeing 4 and 6. 4 and 6, 4 plus 6 equals 10. Great. 4 times 6 equals 24. I am good to go. So, like we said, factoring, we write our factors as the product of binomials or polynomials. So I know I'm going to be multiplying two things together, and I know that my numbers that give me back this polynomial are 4 and 6, right? So let's think about, is there a way that I can check and make sure that these are the factors? Because sometimes we might run into some examples that might have more than one pair of factors that will multiply, but the signs of them will add to different things. So let's FOIL this back out and see if we get the original back. So I will get x squared plus 6x plus 4x plus 24, which can be simplified to this. So we're good. So those are my factors. So let me rewrite it here so that we can see it nice and clear. That is my final answer. Now, we can switch these around. That's totally fine. The order of them does not matter because multiplication is commutative. So either one is good. Okay, let's try another one. Okay, example 9. So again, I'm looking for numbers that add to 13, multiply to 36. So let's figure out what my factors of 36 are that will add to 13. So I have 1 and 36. 2 and 18, 3 and 12, 4 and 9, 6 and 6. So let's see, which of these is going to add to 13? It looks like that pair, right? 4 plus 9 is 13. 4 times 9 is 36. I think we're good there. So my factors are just, again, x plus 4 and x plus 9. Again, we could switch them, totally fine. Either of those are good. Okay, let's keep it going. I want you guys to try this one and yeah, try this one. Okay, so same thing, factors of 36. I have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So this one is slightly different. So I need my numbers to add to 5, but multiply to a negative 36. Now, if I am ever multiplying anything to a negative number, right, one of those things that I'm multiplying is going to be negative, right? I'm never going to do x times x and give me a negative x. It's not going to happen. Negative x squared, sure. Okay, so I know that one of these factors has to be negative. It looks like I can get a 5 out of these two though, right? I can get a 5 from 4 and 9 by doing 9 minus 4, right? That gives me a 5. What if I do 9 times negative 4? Does that give me a negative 36? It does. So it looks like my 9 in my factor is going to be positive, and my 4 in my other factor is going to be negative. Now, this can be switched. This is fine. But we cannot switch the signs that are with each of my numbers, right? If I was to switch them and make my 9 negative, what's happening? Make my 9 negative and add a 4, right? That gives me a negative 5. That's not what I want. I need a positive 5. So we cannot switch our signs. We can switch the groups, but we cannot switch the signs. Okay, try example 11. I do want to say, do not forget about rule number 1. Okay, so rule number 1, it looks like I have a GCF here. All 3 of my terms have a 2 in common, so let's take that out first. Okay, that's out. Now I need to factor this guy. So again, factors of 21. I think this is going to be a pretty short list. That's it. Okay, and which of these pairs is going to give me a negative 10? What do you think? It's this one, 3 and 7. But again, let's think about the signs that are going to go with those numbers, right? 3 plus 7 is not going to give me a negative 10. So I need to think, maybe negative 3 minus 7. Will that give me a negative 10? Great. If I do negative 3 times negative 7, does that give me a positive 21? It does. So that is my signs of my factors. Don't forget this too. It's still a part of my expression. So I have a negative and a negative. And that is the final answer. Okay. Let's try 13. Okay. Again, do I have a GCF? Doesn't look like it, so I think I'm good to go. Looking for numbers that add to negative 10, multiply to 25. Looks like I have 1 and 25 and 5 and 5. Okay, looks like those are my pair. I know they're both going to be negative because -5 minus 5 gives me a -10, and -5 times -5 gives me a positive 25. Okay, now I'm seeing something that is looking a little bit familiar, right? I have something, x minus 5, that is just being multiplied by itself one more time, right? So really, we can write this as x minus 5 squared. That is just the same exact thing. That is more accurate. Okay, so do this reflection here. Explain in your own words how to use rule number 1, and make sure that you are starring or making any questions that you have on your paper so you can ask when we get back from break. Okay.